Right. Good morning, track community, first of all. Welcome. My name's Steve O'Brien, as you've already heard, and 38 years, that's a long time, absolutely a long time. And as Beth said, you know, my sort of current role is now to sort of nourish and to pass down my knowledge, because I can't give them much more than the jobs, but I can pass my knowledge and expertise back down to them. So we're going to be talking today about the importance of delivering a quality S&C renewal, leaving a reliable, high-performing asset. Well, what does that actually mean? That's the first thing we want to get across. So being in the route engineering team, I understand the challenges that you lot have. Being in the asset engineering, I know the problem. Being as a previous TME, I know the challenges again. It's not easy out there. It is very difficult. One of the first things that we did when I came into technical authority was to move the perception that it's, you know, pipe and slippers, you put your feet under the table. It is not that, believe me. It is nowhere near that. It is a really hard, challenging, difficult job. And it covers, you know, the whole railway. So my first role was to get all of my team out there, actually onto the ground to see what's going on and to learn. So let's carry on with this one. So, not broken it yet, that's good. Typical modern S&C renewal. So, we've got a couple of sites here. One is down in Reading and one is at Southall. That's just recently been done a couple of weeks ago. So, why am I showing you this? It's just to give you an overview of what an S&C renewal looks like. It's very complex. It's a lot of machinery, a lot of stuff going on, and it's very, very expensive. It's about £1.2 to £1.4 million per point end, so it's not cheap. So to get the right fix is really, really important. Now, following this is quite key, and I have been on the other side of this. Track bed investigations. It's something that we do, it's a process. Well, no, it is not a process. It's something that's a necessity to actually get the right design on the ground to maximise the amount of usage from your S&C. So what is the actual usage? So we're looking at between 500 and 700 million gross tonnes. That's the sort of average that we get. And you might think, oh, that lasts forever, but it doesn't. You've got certain parts like in Wales and Western, they have 75 million gross tonnes per year. That's massive. And that's why obviously Wales and Western are struggling, as John says. When something goes wrong, the trains will just stack up. And if you've never experienced it's not something to recommend, but when something does go wrong and you're crawling into Paddington from Reading and you're stopping at every signal, then you get to the concourse and it's a complete mob with loads of people, you've got children crying, people's suitcases, one going on holiday. It is not nice. And you know, when the trains are there, it's just absolutely rammed. You've got people trying to get off and people trying to get on. It's just complete carnage. It is not a safe environment, and it's not really how we should be having our 21st century railway. You know, that is not the vision we want. But just going back to this, you know, so the S&C, you know, it's in several parts. You know, we have the rail pads and the undersleeper pads, we have the ballast, we have the formation, and in a well-constructed element, it all comes together to provide the essential and the elastical loading and unloading of the train passage. So if we get it right, we actually maximise it. If we don't get it right, we end up with a lot of problems. And we'll be talking about the problems in a minute. Now, NR60 Mark II, we spoke about this, and this is a really, really high-performing asset. And if you think about a lot of the NR56 and the Mark I NR60s, there's been lots of failures. But what is the real problem? So you've got a graph there shown behind you, and I'm quite impressed with these graphs. I used to just like the little bar charts, and Wade come along and he says, Steve, you're so old-fashioned. These are the Power BI. These are called ribbon charts, and I actually quite love them. They work really, really well. So what this is showing, this is showing it year on year, and you can see the nice sort of orangey colours. These are all of your crossings that have broken. So 75% of our crossings, on average per year, are NR56V. 18% are the NR60 Mark I. So it's a massive chunk, and you might think, yeah, it's probably down to the proportion that we've got, but we'll come to that in a minute. Now, with the standard, the 2102 standard, it actually specifies as an amber clause that for track Cat 1 and Cat 1A and sum of 2 that you should be installing an NR60 type S&C. Lots of the routes are not doing that, and they have their own TVs against doing that. And we've got to start to look at why that is. Now, we are having a lot of broken crossings, and as you can see, most of them are NR56Vs. Now, they do not work very well for areas that have a lot of unsupported settlement, and we'll come across that in a sec. So these are designed to generate your sort of 751 type defects. Now, this is probably something that's quite common to you all. So just take a moment and just read the bottom clause. So in this scenario, it's all about trying to reduce the unit rates. Now, as an ex-RAM, that is something that you're really pushed against. Get the costs down, get the costs down. It's got to be cheaper. But what we're actually doing, we're setting ourselves up for a bit of a fall, because we're looking at, the TBI says put in geocells and put in sand blankets and separators and all this sort of stuff. And what do? The TBI, no, we're totally going to ignore it. So number one, why are we even bothering to pay for a TBI, which is telling us what we need to do? We then ignore it, put in what we think we know, and we're not the experts for the ground-bearing scenarios, and we're then very surprised when our crossings break. It just doesn't line up. So we end up with, trying to reduce the unit rates does have unintended consequences. Now, this is just a crossing. I don't know if it will work. Yeah, it seems to be working. So this is just showing a typical area of S&C that voids. I know I've picked it out as in East Midlands, but this is very common to a lot of areas. And when we're talking about the voidings, we're looking at about an air gap of between 10 and 20 millimetres from the underside of the ballast. Now, unlike CWR will follow the curvature of the track, where with S&C, because it is double the stiffness of CWR, it actually bridges it. So if you're doing a track inspection, you'll see that it looks absolutely perfect. But obviously, in real life, you're putting massive loads into your S&C. Now, just to give a bit of an idea, 4 millimetres voiding is sort of thereabouts where the design parameters work. So we can pretty much all day long work on that. As soon as you go over 4 mil, and in this case, this went up to about 15 millimetres in certain areas, you start to introduce fatigue. And then a lot of the fatigue start from within the internal ribs of the crossing, and then gradually works its way out, and then you start to see the foot failures. So this is where we are installing an NR56 where it should have been an NR60, and we're starting to get differential settlement. This is it again, but in slow motion. I don't know if it'll work. Will it work? Do I need to press it again? Oops. Oh, some say it's like an underground train. So this is just a slow motion, just to show you what's obviously happening. So when we go out and we start to see, ballast attrition. So this is obviously when we call it rotational ballast on sleeper ends. We start to see elements like this. There's a lot of energy going into it, and it does actually start to cause a lot of problems. So will that work again, or is it going to the next one? All right. This is Wales and Western now. Now, we was asked in technical authority, we were asked to go down to Wales and Western to actually try and understand what was going on and why we're getting so many sort of failures. And when we saw this site, we showed it to the engineer, and they thought, we better get out and do some stuff. Now, this crossing went in, this whole layout went in. It's a 1 in 15 ED8 centre block crossing on CEN 56 modular bearers, 40 million gross tonnes, 125 through route. And it broke, I think, about 4 or 5 times. 4 times it's broken since its installation, with the last crossing lasting 10 months. Now, we were sent down there, and we were told that whatever happens, this crossing must not break. And you might think, well, okay, why is that? I'll tell you why that was. Because it's the link to take you down to the Windsor, and it was the King's coronation. So we could not cut Windsor off from the western route. But, we learnt a heck of a lot of work from that. So differential ballast settlement, this is a sort of a nice sort of simple graph that shows you what it looks like. So, with a de-scoped or a poorly constructed S&C renewal, such as a skim dig or removal of a TBI element, the settlement of the bearers can increase relatively to its adjacent bearers. And then once that force is created, you start to get the movement and the flexure, and eventually you will start to get the 751 cracks on the foot. So this is an example of a shroud plate removed off. You can see the bearer differential settlement. You can see the top right the Vosler screw that's broken in plasticity, and it just shows how the impact is. So the 12mm void that we're getting is what that white gap is, and we have got test and trials that we've done on the Western region, which has allowed us to provide support to that. So just to give you a couple of little photographs of what things look like. So picture number one, that is the underside of a bearer within the wheel transfer zone. And honestly, you can slide your hand underneath it. So in a unloaded, that's what it looks like. As soon as it's loaded, the bottom of the bearer makes contact with the formation, and it then causes a bit like a trampoline. Number two is where you saw the rotational ballast. This is what it ends up, takes you down to rebar. Number three is the Voslo SS8163 screws. So as the joint starts to move, you end up in a plastic mode and it breaks. Number four is showing you a 751 typical defect. Number five is showing you ballast attrition again, where the ballast is bouncing around on the sleeper ends due to lack of support. And number six is showing you the damage to the side of the bearer following can going. So what is the size of the problem? 751 defects, on average we have about 74 crossings that have a UIC 751 or crack emanating from the foot every year. And it goes up and down, obviously because we've had COVID, but it sort of averages out around sort of 74. On top of that, we have about 6 crossings that break in two. So they're not into that one. So we then start to look at, okay, split it by region. This is where these ribbon graphs are brilliant out of Power BI. I don't know how to do it, honestly. So we have here, looking at this one, this year, North West and Central have had the highest proportion, followed by Southern, followed by Eastern, followed by Wales and Western. So you might think, well, why are we worried about Wales and Western? They're at the bottom, of course they are. But this is all the defects. When we start to look at the ones that are affected by service-affecting failures, boom, there it goes. Wales and Western is right at the top, followed by Southern, then Eastern, and then North West and Central. Now, if we have a look at the sort of cost to the business that we have, so you might think, okay, all right, fair enough. But when we start to look at the efficiencies, it's good to go all the way back to the beginning. When we start looking at the efficiencies of de-scoping the activities, we're looking at putting in a 56 rather than an NR60. What does it actually cost? So you've made a bit of a savings, but when you start looking at the business, it's about £9.4 million just on the 751 defects. You think, well, blimey, how's that? 74 crossings, average crossing about 35k, is about 2.6 mil. 74 crossings to install is about £3,000, that's 220 odd k. The average delays is about 3.6 million, and then the broken crossings are about £3 million on that. So it's a big chunk of money. So when you start looking at the savings at the beginning to what it's going to be costing, the headache of maintenance, it doesn't sort of stack up. Now then, when we start to look at all service-affecting crack-type defects, you can see straight away 751s are right at the top, followed by the 7111s, and guess what we're looking at next? Then it's 71113s and 762. So we know that we're getting the failures. We know that we're getting the failures from the bottom. From bottom up, we're also getting the failures from the top down. Now, the top down do not get the service-affecting failures as yet. Right, last slide. I've got 2 minutes and I've gone over. Sorry, Ian. Right, CP7. And I have written this, and I do know that this is really, really difficult. CP7 is going to be challenging, a very challenging control period for the rail network. Any savings that we can make, efficiencies and unit rate improvements are going to be sought from the CapEx work bank. We've got to try and make them efficiencies and savings. Track access is also challenging, but have we asked the TOCs if we can have an extra bit, if we've got a more particular difficult crossing to S&C layout to be done? We need to, obviously, challenges will be made to reduce the renewal scope. We know that. Routes and regions are making concisive decisions to reduce the cost of renewals, but they're opting for 56V rather than NR60 for high-speed layout. So test your theory. So you might be making a bit of a savings at the beginning, but it's going to be costing you a whole lot more later on. We can't afford a gold-plated renewal, we know that, but we also can't afford a not fit-for-purpose renewal. And the business can't afford the £9.4 million bill for premature crossing value just on 751 foot fatigue crossings only. I think that's me done. Yep, that's all done. Thank you very much.